Hello everybody and welcome back to more of the 2003 Cayley contest. I'm Root Beer and we're going to be looking at question number 24 in this video. So let's get our pens and papers ready and we can see how, well at least how I did this question. You might have had a different solution. Okay, so what was the question asking? Question 24, in how many ways can A, B, C, and D be chosen from the set 0, 1, 2, all the way up to 9? So we're talking about single digits here. So I'm thinking we might be viewing that we got 4 digits here, so maybe we're going to be constructing 4-digit numbers in secret. Let's see here. So be chosen from the set so that A is less than B is less than, so they go in increasing order. And A plus B plus C plus D is a multiple of 3. Ooh, okay. So the fact that we've got single digits here doesn't really help. To me, usually when you list 0, 1, 2, 3, 4, all the way up to 9, you're sort of hinting that you might want to view them as specifically digits of, and in this case it would be a 4-digit number. So the fact that they have 0 included here when we're not, either there's some 4-digit numbers hidden here, there'd be multiples of 3 probably, or there's some other reason why that 0 is there, because why didn't they just do 1, 2, 3 all the way up to 10? Okay, if they want 10 numbers to choose from. So anytime I see a 0, I think it's a little odd. Unless a computer scientist made this question, because computer scientists typically start counting at 0. And maybe that's it. Maybe I'm just being a little paranoid. But we're looking for 4 so that they add up to 3. So no numbers can be the same, because A is less than B is less than C is less than D. I have to add up to a multiple of 3, and that's about it. So, I'm trying to think, is there a way to view this as a problem involving the 4-digit numbers that I had so predicted? Because if I had a 4-digit number, let's go here, so if I had it, A can be 0, so we should probably make D the first number. But if I had DCBA, sort of like 4, 3, 2, 1 as a 4-digit number, this is going to be a multiple of 3, exactly 1, so this is called the divisibility rule. If the sum divides 3, then the 4-digit number is divisible by 3. So if D plus C plus B plus A is a multiple of 3, then the D1000 C100 BTA is a multiple of 3. But I'm not seeing a good way to do that. Let's see if we can just come up with an example of one that's a multiple of 3. So we've got the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now if we're going to, they want us to tell us how many ways can they be. So we're going to be trying to enumerate them, and just looking at the numbers that we've got as potential answers, 54, 64, 90, 63, 72, these are some big numbers. So I'm probably not going to list them all out, or at least I probably shouldn't be trying to list them all out. You know, if you have reached this point and you looked at 25 and said, I have no idea what's going on there, but I could probably get 24, and you've got 15 minutes left in your hour. First of all, if you're that good, you should probably take another look at 25. But if you had 15 minutes, you could probably list all of them out. I mean, if the answer is 90, which it might be, then that's going to be a bit long. But if it turned out there were only 54 of them, you could probably achieve that. Knowing that there's only 54, though, that's a bit of a different story. So, to avoid trying to list them all out, a good way to do things sometimes is working with cases, or another good way to do things is figuring out how many ways you can not get multiples of 3, and then if you know the total number of ways we can choose these 4 digits from the set of 10 numbers, which incidentally is 10 choose 4, then you can just subtract. Probably have to do cases. It feels like a case question, but I don't know what cases yet. So I'm actually going to try and figure out a set of 4 that I can at least use as an example. And I would say, knowing that this 0 is here, is sort of an obvious one to use. 0, 3, 6, 9. Because they've included 0 rather than, say, putting 10 here, we have exactly 4 different multiples of 3. So I can be really confident that 0 plus 3 plus 6 plus 9, that's 18, and that is definitely a multiple of 3. And that's going to be the only one that has, because they all have to be distinct, so that's the only way to do this. Only one way to do this with all the 4 numbers being chosen being multiples of 3. Okay. And so when I realize that, then suddenly an idea occurs. We could do some cases and say, well, what if we only had 3 multiples of 3 to choose from? 0, 3, 6. And then the fourth number that we choose, whatever it is, he has to fall in. He's not a multiple of 3, so he has to fall somewhere in there, and you get a nice little order. So can it be done with only 3 multiples of 3 and some other non-multiple 3 of number? How about 2 multiples of 3, 1 multiple of 3, no multiples of 3? These are the things that, that's only 5 cases. One of them is already done, and I think that's probably going to be a good way to do this question. So, in fact, there's going to be no way to do it with 3 multiples of 3. Okay, so we're going to do cases here. Based on the number of multiples of 3 we pick. So if we pick 4 of them, the only way to do that is 0 plus 3 plus 6 plus 9. So that definitely works. If we were to have 3 multiples of 3, let's say A, B, and C were the multiples of 3, and D is the other number that we chose, and that's equal to some K, which is a multiple of 3. If I rearrange, then D is going to have to be K minus A minus B minus C. All of these are a multiple of 3, so this is a multiple of 3, and therefore D is a multiple of 3. But we said only A, B, and C were multiples of 3. So this can't ever work. D would be a 4th multiple of 3, and we'd be back in the first case. Think about it this way. If we had 0 plus 3 plus 6 plus D is equal to, I don't know, just say another multiple of 3, 21 or something like that. Not 21, that's too big, 15. Okay, if you rearrange, D is going to have to be a multiple of 3, specifically 6. And that's not allowed for different reasons. But the point is, D has to be a multiple of 3 if you have 3 other multiples of 3. So there's nothing for this case. So already I'm feeling pretty confident. We have 2 multiples of 3, 1 multiple of 3, or no multiples of 3 left to choose from. Okay. And we already have 1 case. So I might think there might be an odd number, but if I was going to guess right now, 63 is the only odd-numbered one, and I know I have an odd case sitting out there. So I might think C. If I had to guess, and if I had like 2 seconds left, I would guess C at this point. Just knowing that when I have 4 multiples of 3, I have 1 case. To me, there should be some symmetries in the other cases that might make them even or multiples of 3 or something like that. Okay. So if I have 2 multiples of 3, what can we do here? So let's say A and B are multiples of 3. So 3 divides A and B. And A plus B plus C plus D is equal to K. Okay? And 3 divides K. So then C plus D, just like in the last case, we can see that 3 divides K, 3 divides A, 3 divides B, so 3 divides their difference. And that's the same as c plus d. So 3 divides c plus d. So to choose our other two numbers, they have to add to a multiple of 3, but can't be multiples of 3 themselves. So we're looking at things like 1 and 2, 1 and 5, 1 and 8. Looking at things like 4 and 2, 4 and 5. You'll notice that in the question they said C is less than D. I'm ignoring that right now. Once I choose my numbers, they just automatically will arrange to have, I chose C to be 4 and B to be 2 and A to be 0 and D to be 9. They'll arrange themselves properly. I'm just looking at pairs of other digits here. 4 and 8, and then we can have 7 and 2, 7 and 5, and 7 and 8. All right. To make a multiple of 3, we need one number with a remainder of 1 when we divide by 3. And one number with a remainder of 2. Because then the remainder of 1 and the remainder of 2, they add up to be a remainder of 3, which gives us a multiple of 3. So there's 3 numbers, 1, 4, and 7, with a remainder of 1. And then there's 3 numbers, 2, 5, and 8, with a remainder of 2. So we pick any one of these ones, the 1, 3, 4, and 7. We pick any one of these ones, the 2, 5, and 8. So that means 3 times 3 equals 9 cases. And then we haven't actually chosen our A and our B. There's 4 multiples of 3. We choose 2 of them. So you can either use, if you know it, 4 choose 2 binomial coefficients. That's 4 factorial over 2 factorial over 4 minus 2 factorial, and that'll be 6. Or you can just pretty quickly list them out. We could choose 0 and 3, we could choose 0 and 6, we could choose 0 and 9, we could choose 3 and 6, 3 and 9, or 6 and 9. Either way, we can see that there's 6 cases. So 6 ways to choose our multiples of 3, 9 ways to choose our non-multiples of 3. We're looking at 54 right here. So that's 54 cases. So combining that with the one case we already know where everything is a multiple of 3, we've got 55 cases. And if we take a look, we have eliminated A as a possibility. Okay? And I'm starting to feel a little worried about C. Yes, we're still getting odd numbers, so that should support C, but we've got 2 more cases to go through. So I'm thinking maybe 90 or 72 now, because it looks like these cases are going to get larger and larger. Okay, so now what happens if we have 2 multiples of, one multiple of 3, one multiple of 3. Okay, we need 1 multiple of 3, and then 3 non-multiples of 3. Okay. If we look at it from the level of remainders, we've got 1s and 2s. In fact, we could even list out our numbers again. And just list them by remainder of 7, 8, 9. So that's a remainder of 0, 1, 2, 0, 1, 2, 0, 1, 2, 0. Okay. Let's suppose I chose something with a remainder of 1. Okay. So then I've got a 0 plus a 1 plus 2 other remainders, and that needs to be something like 3 or 6 or something like that. I could have 2 more 1s, and that would give me a 3. So 2 more remainders of 1, maybe I chose 4, maybe I chose 7. I could choose a remainder of 1 and a remainder of 2, but that would give me a total of 4. Or I could choose 2 2s, and that would give me 5, and neither of those will work. So if I have one remainder of 1, I have to have the other two remainders of 1. By the same reasoning, I have to have, if I have one remainder of 2, I'll have to have two other remainders of 2 to get a total remainder of 6, which is a multiple of 3. Okay. Now, fortunately, there are 3 things with a remainder of 1 that we can choose from. There's exactly 3, just like there's exactly 3 to choose from for remainders of 2. So, we pick one of our 4 multiples of 3 and pick either having the rest have remainder 1 or 2, and that's a choice of 2 things. If I pick this 1, then automatically I've got 1, 4, and 7. If I pick this 2, automatically I've got 2, 5, and 8. There's no other choices after this. So we have 4 things, and then we have 2 other choices to make. So 4 times 2, 8 cases. I was expecting there to be more cases. So that's 55 plus 8. So in total, we've got 63 cases so far. Okay? And now we have 0 multiples of 3. Okay. So 0 multiples of 3, and then that'd be 4 non-multiples of 3. Okay? As long as we have at least one case, at least 2 cases, we know we've got either D or E as our final answer. Okay? So even right now, I could probably list 1, 2, 4, and 5, and 1, 2, 7, and 8. That's 2 cases. That would be 65 cases right here. Okay? So at this point, I don't even have the answer yet, but I know it can't be 54, so A's out. It can't be 64, so B's out, and it can't be 63, C's out. I have 65 cases, so those 3, there's too few accounted for. So my answer is either 90 or 72. So I make this little mental note in case I run out of time. Okay, if I run out of time, I'll just pick. Do I think there's likely to be a lot more left? Then 90. If I think we're sort of nearing the end, then 72 cases. I choose between D and E. I've narrowed it down to 2 choices, 50-50 chance. And for a C-part question, that's certainly worth it. But let's soldier on it and then see what else we can do here. Okay. So if I have 0 multiples of 3, if we look at the remainders again, what could I have? Could I have... Well, I can't have 4 remainders of 1, because that would give me a total of 4 as my remainder, which is really just 1 if we're doing modular arithmetic. So that's essentially a remainder of 1 when we divide by 3. We want a remainder of 0 here. And also something complicating matters is I don't have 4 numbers that give me a remainder of 1. I have 3. We noted that in the last question. I could have 3 1s. Those definitely exist, but then I'd have to have, not a 1, I'd have to have a 2. And that would give me a remainder of 2, not a multiple of 3. Well, maybe I just have 2 1s and 2 2s. Or a 1 and 3 2s, or I could have all 2s. So let's look at the remainders I would get when I divide such numbers by 3. This one will get 6, and that gives me a remainder of 0, so that's something to go for. This one is 7, and this one's 8. And those are remainders of 1 and 2 respectively. So the only way to get A plus B plus C plus D to be a multiple of 3 is to choose 2 numbers that have a remainder of 1 and 2 numbers that have a remainder of 2. So we need 2 with remainder 1 and 2 with remainder 2. So my remainder 1 numbers, I have 1, 4, and 7. And my remainder 2 numbers, I have 2, 5, and 8. Okay. So if I wanted to, say, do choose notation, I have 3, and I want to choose 2 of them. And for my choices of remainder 2, I would use 3, choose 2. And both of those will turn out to be 3 times 3, which is 9. Another thing I could do is I could list them out. Okay? 1, 4, 2, 5. 1, 4, 2, 8. 1, 4, 5, 8. Okay? 1, 7, 2, 5. 1, 7, 2, 8. 1, 7, 5, 8. 4, 7, 2, 5. 4, 7, 2, 8. 4, 7, 5, 8. Either way, we get 9 cases. Okay? And that's it. We've done everything. We did having 4 multiples of 3, 3 multiples of 3, 2 multiples of 3, 1 multiple of 3, and now we've finally done 0 multiples of 3. So let's add it all up. We had 1, plus there was nothing we could do with only 3 multiples of 3. No way we're going to get something divisible by 3 there. And then we had, I'll have to go back and check because I don't remember, 54, that's what it was. 54, and we just had 9 cases there, and I think it was 8 for the last one. Yeah, 8 cases, because that's what brought it up to 63. Okay, and so that's a total of 54 plus 9 is 63, plus another 9 is 72. And 72, I think that was E. Let's just double check. Yes, it was E. Okay. So that took us a little while, but it just boiled down to casework. How many multiples of 3 for each one? And then from there, it was actually quite quick reasoning once we looked at remainders when we divide by 3, or if you know modular arithmetic, that's just working with doing all math, but just with remainders. And that's something you can look up if you're unfamiliar with it. But yeah, casework and then remainder work, and that got us the answer. So that wasn't so bad, I would say. We got one more question left on this contest, so join me, if you would, for question number 25, which looks like it's going to involve shoelaces. And we'll see if I'm right about that next time. So, I'll see you for question number 25.